And welcome back to part 2 of the Ethernet Love Fest that we started last week, mainly with this little module down here, which was an ENC28J60, cheap, works well, quite small, and connects just via 4 wires. That's the SPI wires plus your power lines, and it's really easy to do. And we connected it last week to this little nano here. Great, all working well. Well, to a point. I left it last week with this sort of web page being shown, and I then proceeded to sort of expand upon that for this week, because we want to send some emails out to this phone, don't we? We said that when we have some kind of monitoring web page like this, that's all very well, but it's all very passive. If something happened right now, you'd want to know about it within a minute or two, and one way of doing that is to send you an email. Well, not you don't want to know about more water tank, but you get the idea. So I proceeded to play about with a few sketches and hit a bit of a road bump, well, a road block actually, because when I was sending out the email, which worked beautifully using the UIP Ethernet drop-in replacement library for this unit, which is why we're using it, of course, because it works with this one. What happened was the email got sent and I suddenly thought, no date and time on it. Now, okay, it's not critical because you know when you've received it, but I thought, well, we can do it. We can connect to a network time protocol server, NTP server, and grab the date and time. I already had a sketch that I'd written, well, months ago when we were looking at the ESP8266 wireless module that I will be covering in more depth in a future video, but for now let's stick with the wired one. So I had the sketch to get the date and time, put it all in, wired it all up, made a few corrections to the code so it worked with this one here, and nothing. It would not work. Basically my router was reporting an error saying I've got a UDP null port problem, and well, it wasn't working. So I thought, well, is it me? Is it the sketch? So what I did, I connected up this W51 piece of hardware up, put the same sketch on it to get the network time protocol, and bingo, it worked, no trouble at all. So there's obviously something wrong with the UIP Ethernet library. So I sent an email out to the forum. Norbert, who originally sort of wrote it, or at least brought some threads together, but there was no response on that. I think he's probably moved on. But there was in fact an alternative, well, not an alternative, somebody else has taken on the mantle for UIP Ethernet. They responded very quickly when I raised an issue saying I've taken your new fork of that library and it doesn't compile on my Eclipse IDE. And they said, do this, do that. I did, put the NTP sketch on here, bingo. So we're back in business. So I've had a few highs and lows this week. So what we can say is the UIP Ethernet, I'll put the link to the new updated module on this video, okay, in the comments, not in the comments, in the video description below. So it means we can use this cheap module with full expectation that it's going to do everything we expect it to do. So it's a drop-in replacement for the standard Ethernet library that we'd normally use for a W5100, but you can use both now. Now somebody has commented on the video to say that he thought the UIP Ethernet used more code space, that is compiled. I haven't confirmed that. If that is the case, then well, you could always carry on using the Ethernet library for this one, but if you want to use this one, just use the UIP Ethernet replacement. Great. So that's where we are at the moment. In fact, I'm having to read my notes because there's so many things I just got to whiz through. Now, last week we left it then with this sort of web page being shown. And remember, it was monitoring my water tank. Let me just switch to the browser. Here we are. So this is the browser. We got the pseudo water temperature and all that. And as you can see, this is auto refreshing now because Jim Bob, one of the contributors on my video comments there, said, why don't you stick this metadata into the actual browser itself, the HTML, and it will do that refresh automatically without using that website to refresh this. So that's a brilliant idea, and then what I've included. Now, of course, there's a bit of a clue here with this little message here. So let's go over to the code and just have a look at that. Now, this here you can see it running at the bottom in this debug window as every 5 seconds we have something coming in. And of course, the clue is in these comments here, SD file card contents. So what I've done on this module is, of course, when I started using it last week, it became blindingly obvious. We got this SD card in. I'm thinking, what can I use that for? Now, initially, I assumed, and in fact, it can be used as a logging mechanism. So you've got your Ethernet, you've got your your Arduino running in here, well, under here, and logging stuff to here so you don't lose it, and then perhaps you can use the Ethernet to either grab that data. But I thought, hang on a minute, I'm trying to serve up a web page. I'm having terrible trouble with all that progmem stuff, trying to really shrink it down so we don't run out of space. Why don't I try and put the HTML on this SD card and read from that? Yep, if we have a look at the code, then you'll see exactly what we're doing. So what I've done is comment out, here we are, all this bit here from last week where we're actually reading it from the progmem memory, that is memory that would normally be occupied by your program, but which we've put some strings in it, HTML strings, and it was pretty rough and ready because I had to cut a few corners just to fit it all in. But we've commented all that out this week, and what we're doing, we're saying go to my SD card, so we're opening it up, test.htm, reading the contents, and for each line, just line being determined by this character here, so we're reading this string off the SD card until we hit a new line character, and then we're saying, just like last week, if you can find one of these special variables that I put in there, replace it with the actual value of my local variables, and that obviously is working very well. So the HTML has changed a bit. I'll just show you that very quickly, just so that you can see what the HTML should have looked like, and you can compare that against the progmem type HTML, which I've still got here in this file, but we're not actually using anymore. I haven't included it. So this was the HTML that we put into progmem, and that's still a good technique, don't get me wrong. That's a good technique to use if you've just got a small little bit to put in, but as I say, we did have to sort of squish it in a bit, and some of this HTML is a little bit rough and ready. I mean, it works, and if it works, it's good enough, isn't it, especially for this. But of course there is a better way, and that's writing HTML the way it should be written and putting it on that HTML card. So let's have a look at that. What I'm going to do is take the SD card out of here, stick it into this little adapter that I'm using. This is connected to my PC, and then we can have a look at it in its entirety. Great, let me do that. Be right back. Right, I've removed the SD card, and as you can see, I captured the error now because the unit, this one here, can't read that SD card anymore. I just capture that in a simple if statement and say, okay. Right, let's have a look at the Notepad source then. So this is standard HTML now. By the way, make sure that your file suffix, and as I've shown you in this case, is HTM. I had this as HTML because obviously within Windows we can use long file suffixes now, or file types I should say. That wasn't recognized by this unit here, and it took me right up until this morning to suddenly twig, hang on, this is a FAT formatted card, not FAT32 or anything like that, certainly not NTFS, it's a standard FAT card. Perhaps it is restricted to 8.3 file names. Tried it with HTM, worked like a treat. There is a plus side to that. I can just show you my browser very quickly. Right, so as you can see here, here's my file explorer, and when we highlight this file, it automatically shows a preview of what it looks like. So that's one of the beneficial side effects by calling it HTML. If I kept this as .text, then of course it wouldn't show it. So it means you can play with it in Notepad, save it, and the preview will come up here immediately. You can also show it in your browser, but that's just one way of doing it. Right, let's go back to the code window. Right. So as you can see, the format of this HTML now looks, well, normal in my eyes, but looks much more readable, I hope, in yours. And I've also done a little tweak with it. Here's the body. I've just split all these out to table rows and table data lines so that we can see what, and I've put all the end tags on. These are optional, but I always put them on, and I think any web developer would too, to be quite honest. So that's just spaced out a little bit more, really. Makes it look easy. And I've just added this bit on the bottom here because whilst I was doing this, while I was creating the code, I had a problem with truncation. It seemed to be truncating bits, but I think that was probably just my rubbish code, to be quite honest, because I've put these down the bottom now and they come out just fine. Now, one thing to note then, just going to go back to my workbench. So here's my phone's version of it, and as you can see, I haven't shrunk it at all. It knows it's that size now for my phone, which is brilliant. So there's none of this shrinking, expanding for a phone. And yet on my browser, if I show you the exact same page on the browser, it won't work because I haven't put the SD card back yet. Right, let's take the SD card out of here, which was what I was showing you in Notepad, put it back into the actual socket here. Now when you do this, I've noticed it has errored, as you can see on that browser window up there, and this won't reopen it. I don't know why. It's probably just coding. I think you probably have to reinitialize the SD card or something, or the code for it. So I'm just rebooting this now. Just press the reset. Oh, that's probably long enough. Let's try F5. And there we are. Now, as you can see, the two look very different. So this is on my phone and it's full size. So there's the full size phone version. And on the browser, it obviously looks very different because it's centered and it's wider. How did I do that? Well, because we now have the luxury of writing proper HTML, we can add in a little bit that says, yeah, so here it is, this line here on line 6, well, what we're saying is to the underlying HTML, we're saying, look, stop reporting stuff that you think is correct. I want you to report the exact size of your device now, so that we don't have any kind of scaling effect on the device. So the browser and the phone will now report the true size of what it can do pixel wise, and so that we can now determine exactly what happens on the standard browser, and here what can happen on the phone. And the only reason I've got this as a phone, I've said, look, if I'm in orientation portrait, which of course is meaningless on the browser, but it would mean something to my phone. It's not the way I'd normally do it, but it's good enough for a demo. That's how we do it. Okay, that's pretty easy, isn't it, really? Great. So there we are. So that's one of the pluses now that we can do by using that HTML. Right, let's move on then. First things first, that problem I had with the date and time, I'll just show you that bit of code, but treat it as almost as the black box, really. It's the standard NTP example in the Arduino forum, although there's quite a little nice to know bits about it, and I've tweaked a few bits. In fact, I've hacked the time library that we're using as well, just to show a few more details. So let's do that next. So here's the code for the NTP, and that's the Network Time Protocol server. Now, you have to be a little bit careful with these Network Time Protocol servers, because if you start abusing them, they'll know about it. Now, they won't come knocking on your door, but they'll block your IP address. NTP servers are really only for sort of synchronizing PCs. So, I mean, that's what Windows does, doesn't it? And I'm sure that Apple Macs do as well. Every so often, maybe once a day, perhaps twice a day, they go to an NTP server and they go, what's the time, please? Or date, time, whatever. Drag back the value, compare it to their local time, and go, ooh, you're more than 2 seconds out, I'll adjust your clock. So say your PC clock stays in sync. And that's what this sketch here tries to do as well. Now, obviously, we're going to be using the NTP server to grab a date and time when we send out an email. And that's fine because they'll be infrequent. But if you were to suddenly send out 50 emails in one go for whatever reason, to make 50 calls to the NTP server would not be the way to do it. Okay, so let's have a look at this whole sketch now to see how it works. Now, I will admit I have hacked this a little bit, made it just a little bit more understandable, put loads of comments in it, changed the way it's worked a little bit, not much. And but the beauty of this one is that it does work a bit like a PC would. So what this is doing, okay, it's setting out some stuff at the top here. This is a UK pool of NTP servers. If you're not in the UK, use time.nis.gov. Now I think that's the US one. And if you're in a different part of the world, just Google your NTP server organizational pool and use whatever name they give you. Do not, please do not use an IP address, use the actual name. Why? Because this routine will go to that name and say, give me a random server out of that pool. This is how they do their sort of load balancing, I guess. As you can imagine, all the millions and millions of PCs and things around the world, servers, all trying to get the current date and time. The way they balance that is to go to this sort of high level address, and then that will give you a random, well, not random, but whatever they decide to give you, IP address for an actual server. And that's what this does as well. Now, not only does it do that, This, forget all this bit at the moment. This is where we're setting up the Ethernet stuff, and that there and that there are lines we're going to come back to. So what we're saying is, in my loop, just go and display this clock display. Now some of this is grabbed from the Arduino Playground code, and I've enhanced this a little bit just to make it look a bit more UK like. So what this is saying then is go and display this clock, right? Fine, so that's the date and time, the day of the week. That's it really. What we do, we grab the time here. We say time t, that's a special type, and it's big enough to allow us to have the full value of whatever target we're looking at. So this will always contain the full value of now. Now, we say, okay, go and print the hour, go and print the minutes, go and print the second, weekday, blah, blah, blah. Now what this does then, when it gets this now, and we trap it in variable t, we're using t in all these calls, minute, date, time, and so forth. If we didn't do that, imagine what would happen if we're just about to print the time at, say, 11:59 and 59 seconds. We'd start printing the hour, we'd start printing the minute, and then the seconds has already rolled over, and we'd probably get 0 or 01 or something, and it'd actually be a minute out. And then the day and the month and year could all be out as well. So the idea is you grab it, you snapshot the time at this precise instant in this microsecond, and then use that value to print out a consistent set of values for the hour, minute, second, the day, dates, and so forth. Okay, so what this does then, this now, it says, okay, in this sketch I have a variable called now being the current time. Well, actually, it's milliseconds since the 1st of January 1900. That's how it works, okay? And it says, how long has it been since I've synchronized this time with an NTP server? Well, that's the bit that I've changed up here. Normally it'd be, by default, I think every 5 minutes, but I'm saying do it every 12 seconds here, just for demo purposes. And if it says, oh, it's been at least 12 seconds since I've synchronized, how do I synchronize the time? And we say, this is how you synchronize the time. You run a little procedure called get NTP time, which is a little bit further down. Here it is, get NTP time. So that says I'm sending a packet to this time server. Did I get a reply? We're waiting for a bit. Did I get a reply? Oh, yes, I did. Is it the right size and so forth? Fiddle and faddle about with all the bytes and bits, which we're really not interested in as part of the Arduino world, unless you're writing this sort of code, of course. We just want the date and time. We're using this as almost a black box, aren't we? So it gets all the date and time and stuff, converts it into, well, what I'd consider to be sort of standard time. So that's Unix. The value of the time it's getting back is since the 1st of January 1970, which isn't good enough for us. We need to go back to the 1st of January 1900. So we add on a magic number, which is this one here. That's standard. You can Google it. It is the value of how many seconds since the 1st of January 1900 to January the 1st 1970, and that's quite a lot, as you can see. Can't even work it out. 22 million, billion, trillion. We went through that last week. Let's not go there again. Add that on, and then we have this magic value then. Then all this bit here that used to print out I've killed. We don't need that anymore. This is how we send a packet, and this bit here, this begin packet, is the magic bit that says, okay, I'm beginning with my address. Now, is this address an IP address, or is it in fact a name? Now, by name, I mean, is it, you know, something like uk.pool.org, whatever that name was at the top, or is it a, you know, 141.10, whatever. So if it's a name, a high level, domain level name, it will query, give me an IP address of this, please, until it gets one back. So it goes back and says, to a DNS server, that's a domain name server, give me an IP address. And that server that controls the number of servers in that pool will just give you back a random address. We'll show you that in a minute. So it gets back an IP address, calls begin packet again, then goes and actually gets the value and says, okay, I'm done. In fact, it puts it back into packet buffer of that size, which is 48 bytes. Okay, down here. We don't really need to understand how this works because the time value is buried in this 48 byte packet. I don't want to know about that particularly even. I'll tidy this up. I'll get rid of this stuff here, all this commented code, and we'll see this running. But the beauty of this is, remember, is that it will only synchronize the time every 12 seconds now, because I've forced it to do it every 12 seconds. But really it shouldn't be done anywhere near that frequently, because this will run and keep the time ticking along just with your standard Arduino milliseconds count. Right, let's run this, and I'll bring up the debug window, aka serial port, so you can see it. That's the old stuff from last time. So let's connect all this up and see it running. So there we are. Look, it's connected to the UK poolntp.org. It's got an IP address of 87.124.49. It's doing 4 values now. Go and give me the date and time. And then it says, oh, I've got to resynchronize now. So it goes back and gets a totally different IP address. Look, see that? That was different to what it had before. And it says, right, now I'm just going to get the time locally because I don't need to refresh yet. But now, oh, I need to go and get another one. Now, as it happens, here, look, it's got the same IP address. But that's ukpool.ntp.org controlling that. It says, well, this server is the least busy or whatever, and it will give me back whichever IP address it deems most suitable. Now I've got it back again here, but if I let this run and run and run, you'll see that the IP address for the NTP server does change quite frequently. And I'm guessing it's all down to how often those servers are used. Now it's changed again now. So if we just look at the loop here, as this is running, so this is what we're actually running, remember. We're saying display the clock value, and here we are doing it 1, 2, 3, 4 times. But on our fourth call to display the clock value, and that's getting the now value here, the underlying code is now saying, oh, 12 seconds has elapsed. I'm going to resynchronize with your NTP server. Simple black box stuff. Obviously, don't use 12 seconds in your sketch. I mean, you know, how often do you have to resynchronize the time normally? Well, milliseconds isn't that accurate on an Arduino. From my point of view, though, I'm just going to use this to send out mail, aren't I? So I'm not that bothered either, quite frankly. So, you know, once an hour is probably more than enough. Once an email, perhaps. But I won't be specifically saying refresh my time. It will do it automatically in the background. Brilliant stuff. Right, let's get on with the email sending. Right, this is a fairly standard sketch for sending out email. There's a couple of caveats that I'll go through in just a sec. Let's see it working then. All I'm going to do is reset this Arduino because it only sends out one email. So let's reset, and you'll see a few messages down the bottom here once it's rebooted. So it's connecting to my server, sending stuff out. Brilliant, it's email sent. So if we now have a look at my phone, excuse the blue tack, but believe me, I get enough spam mail as it is without showing everybody else. So if we refresh this, and there it is. So it's from Arduino, my best friend, and it's saying the attic water level is in fact too cold. Brilliant. So that's proof that it works. It works every time. That's not an issue at all. Let's think about some of the caveats that you have to bear in mind when sending emails. Okay. Oh, incidentally, we're back on the ENC here rather than the W5100. It works just as well on here with the Ethernet library. And of course, as I mentioned, we haven't got any SD card on here, but here's a couple. These are some big ones that I've had lying around for an absolute age. They work fine. I even did a video on it. And here's a much smaller one. So this is for the same size card as what I'm using in here at the minute. But basically they're electrically pretty similar. So they're both SPI. And these, I mean, these are very cheap indeed. So it's easy enough to wire these up. Of course, if you have got a shield like that, then of course it's just, I don't know, just less mucking about with wires, isn't it? So let's have a look at the code then. Right, here we are. So once again, I've used the same MAC address on here as I did before. That was the MAC address that I was using on the W5100, and try to keep them the same. In fact, I'd say write them on the unit. Why? Because your router is mapping all this, and it's mapping the MAC address against the IP address. And if you start reusing MAC addresses or reusing IP addresses, in fact, then it will get confused. For example, just now I had this as 123 still from last week, and it got really confused because I've just been using 123 on this one here. So it wasn't prepared to let me do that. and the thing is nothing much happens. The code just sort of stalls a bit. There's the IP address of your gateway, which you can do with an IP config. Just load up a Windows command screen and do IP config like this. So here it is, and just type in IP config. So there you get all your IP addresses and stuff, but the one you're interested in is your default gateway, this one here. It probably is going to be something very similar to this, and your DNS server, which is going to be the same as well. Well, this one's a DHCP server, but my DNS server will go via the gateway as well. It will just get forwarded on. So that's how you do that. So back to the code window then. So, okay, we've specified all the addresses. We've created a client object to do all the work. Now these are all the routines that does it. Now let's have a look at, first of all, I'm going to whiz right down to the bottom to the setup. Setup. So here's the setup, and what it's saying is, let's start an Ethernet session with all those addresses I've given it, and then send the email. Send email then, that's right at the top. But you notice there's nothing in the loop here because we only do it once. Don't put send email in your loop. You will have thousands of emails within seconds, and your ISP will probably then block you, thinking you're spamming. Okay, so only do it once and do it on a reset or something. So send email starts up here. So it connects to the server. Now, this is one caveat. I'm using SMTP on my insecure port. So it's port 25. So none of this is encrypted. Okay, because your Arduino hasn't got a hope in hell of actually encrypting any of this on SSL. It won't do it. So I'm using free text SMTP. Now that's fine if you're connecting to your own SMTP, because presumably via the broadband line into your home, it knows exactly who you are because your router's connected to them. So it knows you are you, if you like. Now, if you're trying to connect to Gmail, I'm not quite sure how well that's going to work. So I'm not going to cover it here either. There's probably things on the internet that might cover how to send mail via Gmail. You might have to go through an intermediary, but I'm assuming that most people are connected up to an ISP via their own broadband line. So insecure port it might be, but you're only sending a bit of text, aren't you? Like that message we just saw on my phone. Oh, where is it? Here it is. You know, about the water level and all that. So, you know, it's not exactly secret, is it? Okay, now these are the commands. These are the SMTP commands you have to send in sequence. You have to send a hello, yes, misspelt with a single L. You can send an extended one, as I've mentioned up here, but you don't need that for this. So you send a hello. Now I haven't specified my address after that. Sometimes you might have to. You might have to say hello space and then the IP address that you are, or rather that your device is running at. Well, not that one. It's this one, isn't it? It's actually got an IP address. But I found that not to be necessary. Now I'm saying who it's to. So my from address, which isn't obviously this. It says mail to and then my real address. I'm not letting anybody see that. I get enough spam as it is. Receipt to, well, it's going back to the Arduino, except I've swapped these round for the demo, so it comes to me. Now sending data. So then you send things like, this is just now plain text. To, this is what appears in the email as well. So to, from, the subject, the date. Well, I've put in a rubbish date here deliberately to see what would happen. And actually the mail client is a bit clever than that. It says, well, this is a rubbish date. I'll put the nearest date to this. So I think it changed this to Monday the 1st of March 20, I think it might have kept 2040, but it didn't like the 2369. It changed that to 2359, I think it might have been. Anyway, but that's why we need that NTP date time routine to plug that in there. Or you can just not put it in. It'll just be blank. It's up to you. And then, of course, whatever you want to send, but you must finally send this dot, okay? And then you quit, and that's the end of that. Now, if you notice all these strings that we're sending out, I've got this F prefix, which means they're all being put into progmem. Okay, so that none of this is taking up valuable RAM, because there'll be quite a lot of SRAM stuff here. And if you're a bit short, this would just tip it over the edge. Now, I'm not going to show you my real email addresses as far as I possibly can hide them from you, because you wouldn't believe the spam I get. luckily none of it hits my mailbox because I've got a pre-spam filter, so it all gets put into that and deleted before it even reaches me, and I just check every couple of days to make sure there's no false positives in there. They're not really anymore, so spam all you like, I'm not going to get it. That wasn't a challenge. That was not a challenge. Don't do it. So the get response here, it doesn't wait forever. Having sent something to your SMTP server, like a hello command, for example, it then says, right, I'm waiting for 10 seconds because that's what this little routine does. I think some of this was taken from either the Playground, Arduino Playground that is, or somewhere. I've tidied it all up then, because normally I wouldn't do it like this. I don't think. So let's have a look. Yeah, because this is... Oh yes, I have changed it. I have changed it. This was written differently. This was counting up milliseconds. I go, well, let's blow that. Let's do it properly with millis and all the rest of it. That's how you'd normally do a delay. So what we're saying is we're not going to wait forever. We're just going to wait until we get some kind of response back from the SMTP server. And when we do, we display it. And if the first character of your response is greater than or equal to 4, that means something bad happened and there's no point in continuing. I'll put a link to all the SMTP commands and I can show you some of those now. So here are some of the values. Let me just make this a little bit smaller so we can read it. There we are. Right, so 200 is the standard response code for OK, which is the same as the HTML or HTTP response code. So all these 2s are fine. 3 is sort of instruction or warning or something. But if you hit a 4 or above, as you can see, all these 400s and 500s means something basically went wrong and you can't continue. And that's what that code tries to interpret. So if the byte at the very front of your response, the first byte, is not a 2 or the 3, then it closes the connection down for you. If you do all this and it just doesn't work, you need to fire up TelNet. TelNet is still available in Windows 10, but it's switched off. It's not installed by default, but it is installed in, let me think, Windows 7 by default. 8 I don't know because I never went to Windows 8. But I'll put a link in the video description that tells you exactly how to enable TelNet on Windows 10. I'm afraid if you're a Mac user, you're on your own. I don't use Macs and I wouldn't know how to start using TelNet. I don't even know if it's a command you can use. But within TelNet, you use exactly the same commands as what we've been using here. So all this hello stuff and connect and mail and receipt and sending data to and stuff like that, all those are exactly the same. You type them in exactly as you see them here. If you can get it working in TelNet, then you can see exactly what you're expecting back, and it's probably a little bit easier to program. And that's it. Your setup sends the email, that's all it's doing, calling that routine, and there's nothing in the loop. So you can see it's fairly simple. And if you're incorporating this into that main sketch that we had for, you know, displaying the water temperature or bees in your beehive or whatever, because we're using only one library, now because I've got it running on this little thing down here, I'm using the UIP Ethernet. And if you're running it on that, you can still use that library or use the standard Ethernet library. Just change it to ethernet.h rather than UIP ethernet.h. That's fine. This config library, incidentally, is where I've hidden all those email addresses that I don't want you to see. And that's just a little file I've put back there. Right, that's it then. So we've looked at NTP servers, we've looked at a bit of the UIP library, which I will put a link to the updated version. I strongly recommend you use that. And then it just remains to sort of connect all these 3 sketches together, which is fairly simple. And if you're using HTML on an SD card, as indeed I'm doing now, then that releases a bit more space in your memory for code mem. And SRAM is being saved by the fact you're putting all these sort of strings on screen. So everything has got an F in front of it, S bracket. Right, that's it. So that's how we send an email, that's how we read the time, and that's how we create our web page to fit both mobile phone and desktop. It's a fair amount to take in, but it's really exciting stuff. And I'm going to connect all mine up now and stick it up in the attic to measure my water, just as spring comes in, of course. So I've sort of missed the boat, really, haven't I? It's never going to get that cold anymore, but better late than never, that's what I say. Okay, hope you have fun doing this. If you've got any comments, please do put them in the bottom of this video or ask questions. And it might not be me answering, it might be other people who view this video. I noticed that there's quite a lot of to and fro now between viewers, which is great, and I really appreciate that. And if you've got any suggestions how we might improve this or just do it differently, I mean, you know, there's more than one way to skin a... Oh, I better not say that. Benny's behind me, but you know what I mean. Okay, have fun with it, enjoy, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.